All right, for this review module, we're going to go over particle motion, so specifically position and velocity and acceleration, how they relate to each other using derivatives, but the most important part is going to be how to do your justification. That's where you're going to get your points. All right, so let's start with position. We always define position as the primary function. A lot of times they use the letter S to stand for the position. So then velocity, v of t, is s prime. So they're related by that first derivative. And then acceleration, a of t, is going to be s double prime. Now, in your FRQs, when you come to justify something in a complete sentence, you're going to be asked about the following 8 statements. Is the particle moving to the right or up? Is it moving left or down, and why? Is it at rest? Is it moving towards the origin, away from the origin? Is speeding up, speeding down? When does it change direction? So your first AP exam tip down here is going to be related to how to do those justifications. Okay, so these particle problems show up every year in some form or another. I've collected AP exams for over 20 years now, and there's never been an AP exam that didn't address particle problems. So particle problems show up each year. All right, you can earn super easy points by knowing how to justify. So some good, solid justifications. And even if your conclusion is wrong, but your justification is solid, you can get a point for that. So say it was supposed to go right, but you said left. If at least your justification is right for, it is solid to support that, you can get your point for that. So let's talk about how to justify these things. So if the particle is moving to the right, that is when the values of the velocity are positive. So don't say because it is positive, specify that the values of v of t being equal to s prime of t are greater than 0. Okay, please eliminate the word it from any of your statements. And then moving left or moving down, that the values of the velocity, the first derivative, are less than 0. And then if it's at rest, then the values of v of t are equal to 0. All right, now how do you justify whether something is moving away or towards the origin? In that situation, you're going to want to make some charts that have a couple layers to the charts, a couple of the rows. In movement away or towards the origin, you need to compare s of t to v of t. So you should have a row for what the position values are, and you should have a row for what the velocity values are. And if it's moving toward the origin, then they have opposite signs from each other. And if it's moving away from the origin, when you compare the position to the velocity, they will have the same sign. So for example, if it has negative position and negative velocity, that means it's already left of the origin and it's moving left. So if it's already left and it's moving left, it's getting farther away. If you compare them and say that the position is negative, but the velocity is positive, that means it's starting out on the left side, but it's moving to the right, which means it's going back toward the origin again. All right, for speeding up and slowing down, that's also a comparison. And when we want to talk about that, we're going to compare velocity to acceleration. So again, it's helpful to have 2 rows in your chart, and then it's easy to look for plus minus combinations. So if it's speeding up, you're going to have the same sign. It can be speeding up both in a negative, double negative, or a double positive. And if they are slowing down, it's going to have the opposite sign. Okay, and then last, when a particle changes direction, you're going to have two things. You're going to have the velocity be equal to 0 or 1 over 0, undefined. It's going to have one of those two options and a changing sign. So the velocity is not just enough. It's insufficient if you just stop at, oh, the velocity is equal to 0 or the velocity is equal to undefined. You can't just stop there. You have to make the extra statement of, and it's changing from positive values to negative values, or the other way around. That second part is what completes the justification of it being a change in direction. All right, so let's try a problem here. A particle moving along the line so that its position is given by the function, a cubic function. And S of t is measured in meters and the time is measured in seconds. So we want to find when the acceleration of the particle is 0. So let's look for both the velocity and the acceleration. So our velocity is going to be 3t squared minus 12t plus 8, and the acceleration 6t minus 12. And the time when the velocity would be equal to 0, we just set our velocity equal to 0. Time is 2 seconds, so that does not require any justification. The second question they want to know is the particle speeding up or slowing down, and for us to justify our answer. So we want to compare the value of the velocity at 1 and the value of the acceleration at 1. So the velocity at 1 is going to be 3 minus 12 plus 8. So that's negative 1 meters per second. And the acceleration at 1 would be 6 minus 12, so negative 6 meters per second squared. So the particle has a negative velocity and a negative acceleration. And so this particle is speeding up because v of 1 is less than 0 and a of 1 is less than 0. Okay, so we've established that it has negative velocity and negative acceleration. For our second example, we want to be able to read this graph of the velocity, and we want to find when the particle is changing direction. So we're going to set v of t equal to 0 or undefined. And so we've got a couple times where this is equal to 0. I've got it time 5, time 9, and time 13. There are no places where the velocity is undefined. But it's not going to change direction at time 9 because the velocity is not changing value. The sign of the velocity is staying the same. So the particle will change direction twice. And it changes direction at 5 and 13. And then because v of t equals 0 and is changing sign. Now one of them is going to represent a max and the other will represent a min, depending on how the change of the sign. So that time 5, that would be maximum position because the velocity is equal to 0 and changing from positive to negative. And at time 13, the position would be a minimum because the velocity is 0 and changing from negative to positive. So this is max position, and this one would be minimum position. All right, what are the units for acceleration? So make sure you know how units are going to work. If this velocity is measured in meters per second, then the acceleration is going to be measured in meters per second squared. And we want the value of the acceleration. So the value of the acceleration is the slope of the velocity at 5.5. So we look at this graph here at 5.5, and it has slope of -3. So the acceleration at 5.5 is -3 meters per second squared. All right, so that should be enough for you to get going on the multiple choice and the FRQ for this. And then when we come back from spring break, we will tackle the second half, which is going to be looking at antiderivatives and area. All right, hope you have a great spring break and happy Easter to all of you.